Download this code from codegive.com, link in the description below. OK, let's dive deep into debugging in intellij IDEA using step actions. This will be a comprehensive guide with explanations, examples, and best practices. What is debugging? Debugging is the process of identifying and resolving errors, bugs, in computer programs. It's a crucial part of software development. A debugger is a tool that allows you to step through your code line by line, inspect variables, and understand the flow of execution. intellij IDEA has a powerful and feature-rich debugger that makes this process much easier. Why use step actions? Step actions, step over, step into, step out, etc., are the fundamental commands that let you control the execution of your code during a debugging session. They allow you to precisely observe what's happening at each step, making it easier to pinpoint the source of errors. Setting up your environment. 1. Install intellij IDEA *. Make sure you have intellij IDEA installed. The Community Edition is sufficient for most debugging needs. You can download it from the JetBrains website, https://www.jetbrains.com/idea/ https://www.jetbrains.com/idea. 2. Create a project *. Create a new Java project in intellij IDEA. You can choose any type of project, console application, web application, etc. For this tutorial, we'll keep it simple with a console application. 3. Write some code *. Create a Java class, example main.java, with some code that we can use for debugging. Here's a sample. Setting breakpoints. Breakpoints are markers that tell the debugger to pause execution at a specific line of code. To set a breakpoint, 1. Click in the gutter, the area to the left of the line numbers, next to the line of code where you want to pause execution. A red circle will appear, indicating a breakpoint. Let's set breakpoints on the following lines in our example. *int sum equals add a, b. *return result, inside the add method. *string full message equals greeting plus name plus. Starting the debugger. 1. Run in debug mode *. Right click within the main.java file or in the gutter next to the main method declaration and select debug main.main. You can also use the keyboard shortcut, usually Ctrl+Shift+F9 or Shift+F9. 2. The debug tool window *. intellij IDEA will start the debugger, and the program will execute until it hits the first breakpoint. The debug tool window will open at the bottom of the screen. Understanding the debug tool window. The debug tool window is the heart of the debugging experience. Here's a breakdown of its key sections. *frames * displays the call stack. The call stack shows the sequence of method calls that led to the current point of execution. You can navigate between frames to see the state of variables at different points in the call stack. *variables * shows the values of variables that are in scope at the current execution point. You can inspect primitive values, object properties, and array elements. You can also modify variable values during the debugging session. This can be very powerful for testing different scenarios. *watches * allows you to define custom expressions that are evaluated and displayed during the debugging session. This is useful for tracking values that are not directly visible as local variables. You can add watches by clicking the plus button in the watches pane or by right-clicking on a variable in the variables pane and selecting Add to Watches. Console * shows the standard output and error streams of your application. Threads * displays information about the threads running in your application. This is particularly relevant for multi-threaded applications. Asterisk toolbar asterisk contains the step actions, step over, step into, step out, etc., resume/pause button, and other controls. Step actions, controlling execution. Now, let's explore the step actions in detail. Asterisk step over, F8 executes the current line of code and moves to the next line in the same method. If the current line is a method call, the entire method call is executed without stepping into it. Think of it as skipping over the details of the method call. Asterisk step into, F7 steps into a method call. If the current line is a method call, the debugger will move execution to the first line of code within that method. This is how you dive deeper into the execution flow. If the current line is not a method call, it behaves the same as step over. Asterisk step out, Shift plus F8 executes the remaining code in the current method and returns to the calling method. It moves you up one level in the call stack. Asterisk step into my code, Alt plus Shift plus F7 similar to step into, but it will only step into code that you wrote, i.e., not library code or framework code. This can be helpful when you're only interested in debugging your own application logic. Asterisk run to cursor, Ctrl plus F9 executes the code until the cursor position is reached. This is a quick way to jump to a specific line of code without setting a breakpoint. Asterisk force step into, Ctrl plus Shift plus F7 even if intellij IDEA thinks a method is not user code, force step into will make it step inside that method. Debugging example walkthrough. Let's use our sample code and step actions to understand how debugging works. 1. Start debugging * start the debugger as described above. Execution will pause at the first breakpoint, int sum equals add, a, b. 2. Step over, F8 press F8. The debugger will execute the add, a, b, method call without stepping into it, and then move to the next line, system.out.println, sum, plus sum. Notice that the sum variable in the variables pane now has the value 15. 3. Step into, F7 set a breakpoint inside the add method at return result. Restart the debugger. Execution pauses at int sum equals add, a, b. Now, press F7, step into. 4. The debugger now jumps to the first line inside the add method. Press F8, step over. The debugger steps to return result. You can see X and Y are 5 and 10 respectively and result is 15. 5. Step out, Shift plus F8 while still inside the add method, press Shift plus F8, step out. The debugger will execute the return result statement and return to the main method, pausing at system.out.println, sum, plus sum. 6. Run to cursor, Ctrl plus F9 place the cursor on the line string message equals create message, hello, world. Press Ctrl plus F9, run to cursor. The debugger will execute all code until that line, effectively skipping the multiply method call. 7. Step into my code, Alt plus Shift plus F7 remove the breakpoint you set earlier in the add method, but add a new one in the create message method on the line string full message equals greeting plus name plus. Restart the debugger. Execution pauses at string message equals create message, hello, world. Press Alt plus Shift plus F7. The debugger jumps into create message. Modifying variable values. During a debugging session, you can modify the values of variables. This allows you to test different scenarios without recompiling your code. 1. Pause execution * set a breakpoint in the add method on the line return result, and start the debugger. 2. Modify a variable * in the variables pane, find the x variable. Right-click on it and select set value. Enter a new value, example 100, and press enter. 3. Continue execution * press F8, step over, to continue execution. You'll see that the result variable now reflects the modified value of x. Conditional breakpoints. Sometimes you only want a breakpoint to trigger when a specific condition is met. This is where conditional breakpoints come in handy. 1. Right-click on a breakpoint * right-click on the red breakpoint circle in the gutter. 2. Enter a condition * a dialog will appear. In the condition field, enter a Boolean expression. For example, if you only want the breakpoint in the add method to trigger when y is greater than 5, you would enter y5. 3. Debugging with the condition * now, the breakpoint will only pause execution when the condition is true. Evaluating expressions. IntelliJ IDEA's debugger allows you to evaluate expressions on the fly during a debugging session. This is useful for quickly calculating values or testing code snippets. 1. Select an expression * select the expression in the editor, example x plus y. 2. Evaluate expression * right-click and select Evaluate expression. Or press Alt plus F8. 3. View the result * a dialog will appear showing the result of the expression. You can even execute code snippets in the Evaluate expression window. Common debugging scenarios. Null pointer exceptions * place breakpoints before lines where you suspect a null pointer exception might occur. Inspect variables to see which ones are null. Incorrect loop logic * step through the loop iteration by iteration to understand how the loop variables are changing and where the logic might be flawed. Incorrect method results * step into a method to examine its internal calculations and identify where the incorrect result is being produced. Multi-threading issues * use the threads pane to examine the state of different threads and identify potential race conditions or deadlocks. Tips and best practices. Start small * don't try to debug an entire complex system at once. Start by focusing on the area where you suspect the problem lies. Use breakpoints strategically * place breakpoints at key points in your code to understand the flow of execution. Inspect variables frequently * keep an eye on the values of variables to see how they are changing and whether they are what you expect. Use watches for complex expressions * track values that are not directly visible as local variables. Write unit tests * unit tests are invaluable for catching errors early in the development process, reducing the need for extensive debugging later on. Learn the keyboard shortcuts * mastering the debugger's keyboard shortcuts will significantly speed up your debugging workflow. Don't be afraid to modify code * during a debugging session. You can experiment with changing variable values or modifying code to see how it affects the program's behavior. Remember to revert your changes before committing them to your source control system. Rubber duck debugging * sometimes just explaining the code to someone, or even an inanimate object, like a rubber duck, can help you identify the problem. Logs * use logging statements judiciously to track important events and variable values in your application. Libraries like log4j or slf4j can help you manage logging effectively. Temporarily adding system.out.println statements can also be useful for quick debugging. Remote debugging * IntelliJ IDEA also supports remote debugging, allowing you to debug applications running on remote servers or virtual machines. This is useful for debugging production applications. You'll need to configure the remote JVM with specific debugging arguments, example agent libjdwp equals transport equals dt underscore socket server equals y suspend equals n address equals 5005. Profiling * while debugging helps find functional errors, Profiling helps find performance bottlenecks. intellij IDEA has profiling tools built in or available as plugins. Example of debugging a loop. Let's consider debugging a loop. To debug this loop, you would 1. Set a breakpoint inside the loop at the line sum equals sum plus numbers I. 2. Start the debugger. 3. Use step over, F8, to step through each iteration of the loop. 4. Observe the values of I, numbers I, and sum in the variables pane to understand how the loop is progressing. 5. If you suspect an issue at a particular iteration, you can use a conditional breakpoint, example I equals 3, to only pause execution when I reaches that value. Conclusion. Debugging is a fundamental skill for any software developer. intellij IDEA's debugger provides a powerful and intuitive environment for finding and fixing errors in your code. By mastering the step actions and other debugging features, you can significantly improve your productivity and the quality of your software. Remember to practice regularly and explore the advanced features of the debugger to become a truly effective debugger. Good luck.